Like a waterfall in slow motion.
Hello and welcome to the practice problems video for the section on sinusoidal graphs. Okay, here's number 1. We're asked to sketch a graph of f of x is equal to -3 sine x. Okay, so we notice two things here. First of all, the coefficient of our sine is 3, so that means our amplitude, our a, is equal to 3. Okay, and we also see this negative sign in front, which means that we have to have a vertical reflection. And that would be across the x-axis. Okay, so let's just start off by drawing our normal sine graph. Okay, so let's say here's x, here's f of x. So 1, 2, 3, 1, 2, 3. Let's say here's pi, here's 2 pi. Okay, so this is 1, 3, -1, -3. Okay, so our normal sine graph looks like this. We have 0, 0, 0, pi 0, 2 pi 0, pi over 2, 1, 3 pi over 2, -1. So it kind of just oscillates like this, goes up and down like that, and it continues on in both directions, right? But now what we're going to have is, we don't have any vertical or horizontal shifting. So we're going to start at 0, 0, and our zeros are going to remain in the same places. But the thing is that we have to reflect it vertically, and our new amplitude is going to be a 3. Okay? So reflecting vertically means instead of this shape, we're going to have now this shape here. Okay? So we have to start going down, and now our maximum distance that we can be away from our midline, which is y equals 0 in this case, just a side note there, is going to be 3 and -3. Okay? So we can go like this and like this. So again, we're going in the opposite direction. We're starting off going down because of that negative sign, and then we're going all the way to -3, and we're oscillating in between positive and -3 because our new amplitude is a 3, as denoted by this guy here. Okay, so the correct graph for this one is going to be the one that I just drew, the one that kind of goes up and down at higher heights there from our midline. Alrighty, number 2 asks, given the graph below, determine the amplitude, midline, and period, and then find a formula for the function. Okay, so general formula, just to write that down, get it out there, is a times sine or cosine. So it would either be sine or cosine, we can choose to see which one would fit better, okay, plus k. Or we could use the cosine one, or it could be something like this, and you just replace sine with cosine. It just depends on the shape of your graph and what parameters you kind of want to use. Okay, so let's look and determine, let's see if we can find the amplitude, midline, and period, and then we're going to find the formula for the function. So the thing is, where is this oscillating about? What horizontal line? If we were to pick y equals 0, for example, we could see that definitely we don't go up and down in equal direction, in equal magnitudes, right? Because here we only go down by 1, but here we go up by 3. So this definitely cannot be our midline, this y equals 0. So we're not going to pick that one, but instead we see that our midline should probably be at y equals +1. Because then we can see that, okay, we go down to and up to from that line, so that's good. We have equal movement up and down. So y is now equal to 1, so that means that our midline is given by y equals 1, so that means k is going to be equal to 1. Okay, so that's what we can plug into our formula ultimately. How about the amplitude? Amplitude means how far, the greatest distance that you can go, that your graph can be from your midline. So in this case, that would be 2 units away, right? So because we can go 2 above the midline and 2 below. So that means our amplitude is going to equal a 2. Okay? How about our period? That means the kind of like the time or the distance on your input value, or the range on your input values for which one cycle occurs. Okay? So in this case, we can recognize a cosine shape here because we start up here, we roll down the hill, and then we roll back up. Okay? And that took how long? And then we would look at our input, kind of like our dependent variable axis, our independent variable axis. And so that'd be from 0 to 4 pi. So that means our period is equal to 4 pi. So from this information, we see we have a k. That's good. We have an a, an amplitude. And where's our b? What's going on with that? So to figure out b, we know that period is equal to 2 pi over b for sine and cosine graphs. So we can just use this equation here. Okay, so we got this part from the graph, we got this part from our formula, so we can just figure out that b is equal to 2 pi over 4 pi. So that's going to be equal to a 1 over 2. Okay, so now we know b, and we can just plug everything into our formula, f of t. So our f of t is going to be equal to amplitude, which is equal to 2. And then we saw that we actually started at the top of the hill, rolled down, and went back up. Okay, so this is the shape of a cosine, so we're going to pick the cosine graph there. We have a 1/2 in front, because that's what we figured out b to be. T minus h, there was no horizontal shifting, because we started at 0, and then the amplitude height. Okay, and then our k was equal to a 1. Alrighty, so just simplifying here, we get that f of t is equal to 2 times cosine t over 2, and then plus a 1.